All right. Good afternoon. I was literally about to send an email. I was surprised, wondering why there was nobody attending class. But we're going to continue our discussion nonetheless. Ms. Nakonde, I wanted to kindly ask if you could help us confirm whether you're able to see my screen. Well, you're probably able to see my screen, but can you hear me just fine? Hello? Miss Erica. Okay, great. Wonderful. So we're going to continue our discussion of lecture series number 8. We're hoping we can, kind of wrap up so that beginning Tuesday, we can actually start looking at the very next lecture series, which is the final lecture series, right? Centered around data presentation. But a reminder that we looked at a broad spectrum of quote-unquote sampling techniques. In fact, we had an extensive discussion of the things that are on the right. Now, if you look at the image where we were looking at probability sampling techniques and non-probability sampling techniques also. And we gave you examples, right? Instances when you may find yourself using one over the other, ideally. More importantly, I guess towards the end yesterday, I think we had an extensive discussion which was centered around characteristics of a good sample. So in other words, given a population, let's say of 30,000 UNZA students, what's some of the things that we ought to take into account when we are sampling, right? Creating a sample. Hopefully we've taken note of some of those important things. In addition, we finally wrapped up by looking at some of the advantages of sampling, most of which were already highlighted at the very beginning, right? When we were trying to compare so-called census and sampling, right? And then we looked at disadvantages, obviously, things that may result in so-called errors. Now, just a few things here associated with sampling errors. It's important that we highlight these things. It turns out that typically when you're conducting, quantitative studies, especially those that will heavily rely on statistical analysis, there are some errors that may result, right? So for instance, we would find a situation where samples are expected to mirror the population from which it comes from. What we're trying to say is, in the event that you wanted to conduct a study at the UNZA, and you, let's say, select a representative sample, the idea behind most of these quantitative studies is that you'd anticipate or expect that the sample is going to be a reflection of the entire population. Now, the unfortunate thing here is there's no guarantee, is it, that the sample that you're using, this representative sample, will precisely be a representation of the entire population. Of course, the aim is to make sure that there are as fewer errors as possible here. So we see here a situation where no sample is going to be an exact mirror of the population. It will be closer to the truth if you are very, very careful here. Now, it turns out that there are some errors that may result here, things like sampling errors. And we're going to talk about these things here, right? With random errors here, we see that, we have a situation where the sample selected is not really representative of the population due to chance, right? Those of you that are conducting studies with UNZA students, because you're pressed with time, you most likely find yourselves in a situation where you probably restrict yourself to collecting data from the School of Education or something like that, right? The problem with that is that the School of Education is not going to be representative of the entire UNZA population, because we know that the characteristics that may be specific to the School of Education may not necessarily be the same as, schools such as the School of Engineering, for instance, or School of Public Health, for instance, right? And we see also that the uncertainty associated with an estimate that is based on data gathered from a sample of the population rather than through a census is what we are calling a sampling error, right? So there are random errors, and then we see that there are also sampling errors, right? So the uncertainty associated with an estimate based on data gathered from a sample. And it turns out that these sampling errors are typically random variations that exist, right, in the sample estimates around the true population parameters. Typically, the relative levels of these sampling errors can be controlled by the sample size. In fact, it's one of the reasons why a couple of slides from now, we're going to look at techniques that we use, right, to determine an appropriate sample size. In fact, this is the reason why there's always an obsession centered around numbers, right? For you to get statistically significant results, in other words, for you to guarantee that the results are not by chance, one of the things you'd have to make sure is that the sample size, right, is appropriate enough for the study itself. Typically, relative to the population, there's a minimum number of cases or elements from where you ought to collect data from. Otherwise, you're probably going to have a whole range of sampling errors. Which is why we are stating in the next point here that typically larger sample sizes will result in smaller sampling errors. And the goal is always to ensure that the data you're collecting is associated with smaller sampling errors. I mean, you can't rule this out completely unless if you conduct a census, is it? Unless if you collect data from the entire population, target population. Now, a few points here as to why, you know, the sample estimates may have uncertainty associated with them. We see here that the estimates of characteristics from the sample can differ from those that would be obtained from the entire population where surveyed, right? A classic example here would be, I'm going to say, minors, right? We see here that if we look at your group, we have a situation where very, very few of you are minoring in mathematics, right? I don't know how many people are minoring in mathematics, but typically, traditionally, we've had very, very few people minoring in mathematics. And so we are faced with a situation where if we were to kind of get information based on minors, quite naturally, and I hope I'll be able to find what I'm looking for here, but quite naturally, we would have a situation where the estimates from that specific characteristic here, you know, may differ, right, from the entire population because we don't have a representative sample like that, you know. If I can get to the part I wanted to get at here, but I can always do this later on here. I wanted to kind of showcase using your class list. Maybe I can get it right away, actually. Showcase exactly what it is I mean. What is this now? I don't know what this is here, but I guess I can always do this later on. I can always do this later on. GRE 2024. You know, I'm just going to get the entire. I'm trying to make sure that people are on the same page as I am here. At least we kind of misrepresent some of these things. So what we're saying is that if we're conducting a study with you guys, right? What we see here is a sort of situation where and I hope there's I don't have the minors actually, which is quite unfortunate. If I put out something, the thing here would have been slightly different. But let's say we wanted to conduct a study centered around, well, we're trying to conduct a study in such a way that we decide to look at the results relative to the various measures, right? You know, it's not really going to help us that much, is it? Because we only have 10 people, right, that are enrolled in the records and archives management, the BARAM program, whereas we have like 116 people enrolled into the ICTs with the education program, right? So it may not be a true representation. And by the way, I'm making an assumption here. In our case, all of these 10 represent the entire population of the BARAM program. So might as well just say, oh, it's okay, I guess, right? But you get the point. Anyway, so there's that. And we see here that the other reason why sample estimates have uncertainty associated with them here is that the estimates from one subset or sample of the population can differ from those based on a different sample from the same population. So in other words, if uncertainty is introduced because if let's say I wanted to conduct a study with you guys, right? I leverage, let's say, random sampling, and I pick, let's say, for argument's sake, 30 of you guys from a population of about 126 of you. I pick 30. I conduct a study. I pick another random sample, right? 30, maybe I exclude those that were picked from the previous study. I do another random sample, and then I pick 30. What we are saying is that the estimate from these two subsets may actually be different, right? So you have what's called a sample-to-sample variation, in other words. Now, a few causes for these, sampling errors are things like chance, right? Remember, this particular example here is tied to probability sampling, is it? Everything is by chance. So we see here that, yeah, I don't know, maybe you can mute your microphone. Thank you very much. Do you suppose? I don't know who that is here, but we'll kindly ask if you can mute your microphone. I think it's Miss Fides. Do you think you can mute your microphone, please?
Window, please. Wait. So much white is it?
No, and listening to this conversation and see what it's all about, because she's clearly not paying attention in class here, and then we know we're gonna embarrass her in class. So we were eavesdropping on your conversation. Miss Mitty, you're gonna mute your microphone here. Don't know what that is about, but anyways, so we see that the sampling error could be by chance, right? And in fact, it turns out that this is the main cause of sampling errors, right? It just occur here because just by chance you probably ended up, sampling the wrong cases, right, or the wrong elements in essence. But also, more importantly, it could be as a result of sampling bias. So this is unfortunate actually, as it relates to newer researchers or people that know too well that if they sample, if they use a specific sampling technique, or they sample from the population in a certain way, they won't really get the results that they want. It's like if I was conducting a study to prove to my superiors that my teaching effectiveness is really so good, right? Perhaps what I may do is I may deliberately sample the population in such a way that it favors the outcome I'm expecting, right? It's like I know that probably the people that will more likely think that I am more effective at teaching are individuals that get really good marks, right? So maybe I sample you guys in such a way that I'm just picking individuals that have been consistently performing well. Now I know that people that will perform well will probably be more inclined to indicate that I'm more effective at teaching or something like that. So sampling bias, in other words. You want to make sure when you're conducting research that you eliminate biasness, right? And biasness is not just tied to a tendency to favor selection here. It will be like you responding to your own research studies. You create a questionnaire and then you're also a respondent, yeah? Anyway, so the chance component, often called random error, exists no matter how careful the selection procedure is implemented, right? So the first reason here always happens, right? And the only way to minimize chance sampling errors is to select sufficiently larger sample size. So what we are saying here is that if you're trying to avoid or reduce the sampling error by working on the errors introduced by chance, what you want to do is you want to make sure that you're working with a relatively large sample size. So the number is important, right? The sample size must be seriously taken into account. Yeah, all right. So those are sampling errors, right? Hopefully we've taken note. But there's also non-sampling errors, is it? So these are types of systematic errors in the design, right? Or conduct of the sampling procedure itself, which will result in the distortion of the sample, so that it is no longer representative of the reference population. So in other words, we see a situation where the errors, in this particular case, the errors are introduced as a result of fundamental flaws in the experimental design or the study design of your research. Yeah. You can eliminate this by carefully designing the sampling procedure and not necessarily increasing the sample size. So in other words, these non-sampling errors will manifest themselves irrespective of whether you've taken into account sampling errors as a result of chance, right? Because you are not methodical enough when you are sampling from the target population. In fact, this, by the way, if you are paying attention, is an error that would likely be introduced if you are leveraging things like multi-stage sampling, right? Where you're using a combination of a series of sampling techniques, ideally. Okay. So really, the solution here is to be careful really when you're designing the sampling procedure here. And it turns out really that non-sampling errors will occur whether the total study population or sample size is being used. Yeah. The issue here is in the design, is it? Yeah, which is why we're saying it's a non-sampling error, right? It has nothing to do with the sampling technique of the sample itself. So these errors will manifest themselves irrespective of whether you're conducting a census or not. Anyways, again, more on errors here, some basic types of non-sampling errors. There's a so-called no response error and response or data errors, right? So a non-response error will occur when the elements or the cases selected as part of the sampling procedure do not respond, right, in whole or in part. So you have a situation where you identify a sample, an appropriate sample from the population, but then you're sitting there and there are fewer responses than expected, right? You're more likely to experience these non-sampling errors. So the idea here is if non-respondents are not different from those that did respond, you really won't expect any no response error. So in other words, if let's say you distribute your questionnaire and you're listing responses, and out of, let's say, out of the I want to argue, let's say out of 100 respondents, you only get 50 respondents, but the 50 that did not respond, are not necessarily different from those that have responded, then you won't really get any no response errors. However, if the opposite happens, then you're certainly going to have response errors, right? Because you don't have responses associated with the missing response, the missing respondents, in other words. And it turns out really that yeah, I don't know what I was about to say here when I said when non-respondents constitute a significant proportion of the sample. Yeah, I guess I'll have to confirm this statement, second statement. I'm not sure what I was about to say here, what I wanted to say, probably hinting at the fact that if the non-respondents constitute a significant proportion of your sample, then you have a situation where you have a significantly larger non-sampling error, ideally. So I guess a ballpark would be 15% or more, right? And then, a response or data error is a systematic bias that occurs during data collection, right? Analysis or interpretation. Yeah, so you have the required number of respondents or data associated with the respondents that you want, but it turns out that errors can still be introduced, right? We're calling these errors response errors or data errors because they're associated with the data that you'd have collected. And what we're saying here is that these are associated with systematic bias, right? That will occur during the data collection itself or when you are interpreting the findings. Yeah. So this could be things like respondent errors, I don't know if you've done this before. I'm sure you have, where maybe a lecturer brings a questionnaire, right? And they're trying to take advantage of the fact that you're a captive audience, is it? It tells you you're not, you only leave here once you fill out the questionnaire. There are researchers like that. Now, because you want to go here, you get this questionnaire and you're just ticking without thinking or reading through the questions, yeah? In other words, you're lying, is it? It's quite common, actually. Actually happens more often than people think, especially in cases where your questionnaire is so lengthy, right? A person may willingly, decide to be a part of your study, but 5 minutes down the line, and they haven't even gotten halfway through answering your questionnaire, right? What do? You just quickly get it over with. They'll just lie, is it? You're just ticking yes, 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 or something, or strongly disagree and all those things. And by the way you get around some of these things sometimes as a researcher is you twist the question somehow, is it? If you have a number of Likert-like scale questions or items, what you do is you strongly agree for some questions will be on the far left, but for some questions will be on the far right, so that you're able to easily filter out respondents that would be lying or something like that. Anyway, there could also be these are response errors as a result of interviewer bias. So you're conducting interviews and your probing or your questioning is more biased, right, towards an outcome that you're anticipating, right? Could be issues to do with recording errors, right? This actually happens often when you're dealing with paper-based questionnaires, especially. There's a group, I can't remember which group, which I was advising against using a paper-based questionnaire. I mean, it's 2025, right? Why? Right? If you're conducting a study at UNZA, what would possibly be possessing you to use a paper-based questionnaire, right? The paper-based questionnaire is going to require that you transcribe that data, right? If you have a 2-page questionnaire, you're going to sit there. You're moving the data which is in the pencil and paper questionnaire to maybe a spreadsheet so that you analyze the data. Now, if you have like 100 responses, there's a likelihood that you may have recording errors, right? And then, of course, there's poorly designed, questionnaires. Instead of using category questions, right, you're using list questions, for instance. Instead of using Likert-like scale items or questions, what you're doing is you're using open-ended questions, right? Poorly designed questionnaires. Or you have a very weird questionnaire where you're not capturing demographic factors. Yeah? So a poorly designed questionnaire will lead to response or data errors. Again, these errors are introduced during process of data collection and interpretation also. And typically what we see is that, these sort of systematic errors will make survey results especially unrepresentative of the target population, right? Because they will distort the estimate in one direction. And then again, we see that random errors can distort the results in any given direction. So I thought now would be a good a time as any, seeing as we have an idea of what sort of errors can be introduced during research design as it relates to sampling. Now would be a perfect time for us to talk about an important topic tied to participant recruitment, is it? So you have your instrument, you've created your instrument, and you've identified to say, we're going to use stratified random sampling, or we're going to use cluster sampling, or we're going to use snowball sampling. The question to ask is that how do you go about recruiting participants? It's hard to recruit participants. It's really hard to recruit participants here. So typically what you would perhaps do is you'd find yourself in a situation where you've used a particular sampling technique to create a list of potential participants, right? You've identified your target group, right? The next step here is you have got to use that list to get an actual sample, the actual sample that you're looking for. Yeah. Now it's like if you're targeting School of Education students, right? The question is, you figured out that one of the parameters you're using, you're going to leverage random sampling, but you're going to get these participants from the School of Education. So what we're trying to appreciate here is the process you're going to have to go through for you to get the people from the School of Education to actually respond to your questionnaire, right, or participate into your interview sessions or something. So really this process of participant recruitment is a practical process of contacting, informing, and persuading, and persuasion is key, by the way, individuals in your sample to take part in your research. Okay? So you're contacting, informing, and persuading. Now you notice here that these things you're doing, right, can be done in so many different ways. Is it a variety of different ways? Contacting, a common thing to do, and I always encourage my students here is, most of them I work with at fourth year, is the easiest way of contacting participants, especially if you're working with students, is WhatsApp. Because everything's on WhatsApp. In fact, I was telling one of the groups, immediately reach out to the course representatives for the various course WhatsApp groups from our department or from the school of education. And through them, have them just post a message, right, in one of the WhatsApp groups, inviting people to participate in the study or something. Yeah, you know, it's difficult here. It's really, really difficult. So informing or contacting these people is one of many steps you've got to go through, right? You've got to persuade people somehow to participate in your study. It's never easy. You know, in some instances, you may need to make sure that you have some sort of incentive or something. I'm sure you've come across studies. If you participate in this research, there's a chance that you win an iPad or something. That's an art. I mean, it's a way of persuading participants to be a part of your study. You know, there's an iPad up for grabs or something. Or we'll randomly do a draw and give any lucky participants airtime or something like that. Now, it's important that we are ethical, right, in how we are conducting this recruitment process. If you're promising people a reward somehow, you must do that, right? You must be ethical, right, when it comes to that. So don't just lie to people so that you lure them into participating in your study. And what we're saying here is the process of recruiting participants here ought to be governed by strict ethical rules, right? Like, for instance, these are things that we discussed when we're looking at ethical consideration, but what we see here is that before you contact a single person, you must understand these principles or you must remind yourself of those principles we discussed, like informed consent, right? If a person does agree to be a part of your study here, right, you must make it clear to them that their participation is going to be voluntary, and they must explicitly indicate that they want to be a part of the study. So they sign an informed consent form and indicate that they are willingly participating in the study, right? So informed consent, voluntary participation, make it known that at any point during the study, they can opt out, decide to leave without providing an explanation here. And then, you know, confidentiality and anonymity, you must indicate to them how you're going to make use of the data you're collecting. Of importance here is emphasizing the fact that the data that will be collected is going to be anonymized, right? And people will not be able to know that Lighton participated in the study itself. Now, here's the thing here, right? Just a thing about response challenges here is hard here. So let's say you have sent out 300 emails, right? You're targeting, let's say, I don't know, it's 100, 200 participants or something, and only 50 students respond to something. I'm trying to give a scenario here of how hard it is to recruit. Recruitment is hard, really, really hard, actually. I'm going to show you something here, a real world example of how hard it can be to recruit participants. Anyway, I can show this to you later on. We conducted a nationwide study with health practitioners in Zambia. We only managed to recruit a total of about, is it 93 participants or something? It was really, really hard, right? Extremely, extremely hard, difficult, painful, frustrating. In fact, we ended up getting a very negative comment, right, as it relates to our findings, when we were writing up our findings, I wanted to showcase some example of messages we were having on a WhatsApp group to try and increase the response rate here, showcase how it's hard here. Now, it turns out that, you know, this problem of low responses is quite common, right? Very, very common, actually. You know, and it's formally called non-response, right? This idea that you identify a sample from where you're going to collect data, and you invite people, you inform people about the study, you invite them, maybe it's via email, via WhatsApp, maybe you put up an ad perhaps on the notice board or something. And what you have is maybe you just have fewer individuals interested in participating in this study, right? So what we are saying here is it's important to define some of these things. We are calling the response rate as a proportion, right, of the selected sample that will actually participate in your study. So whenever you come across a study and they tell you the response rate was maybe 20%, what they're saying is that out of all of the emails that were sent, right, out of all the emails that were sent, only 20% actually responded or participated. In other words, they filled out your questionnaire, for instance, right, or showed up, they're part of interviews or something like that. So the response rate is a proportion of selected sample that actually participate in the study here. Now it turns out that this metric called the response rate here is something that is important, or is a problem here, because it tends to introduce non-response bias, right? If you are paying attention, right? Non-response errors or non-response biases we're talking about previously. And what we see here is, for the example I just gave, where you only have like 50 out of 300. By the way, if we have 50 out of 300, what we're saying is the response rate is 50 divided by 300 times 100, is it? Which is 16%, right? Response rate for this hypothetical example here would be 16.7%. Yeah. So you know, non-response errors will manifest, or non-response bias is going to be the result here, because the 50 who have responded out of the 300 here may be completely different from the other 250, right, who should have responded. So you're not capturing information coming in from those people that would not have responded. Yeah. And what we see here is a situation where, again, there's bias, because the people that may have responded perhaps are the people that were interested or excited enough to participate in the study. Maybe because, and this hypothetical example, I think I was hinting at the new AI system here. I've used it as an example before. So maybe the 50 that have responded are the people that are excited about the new system. Now, there's a problem there, right? Because ideally you'd want to also capture responses coming in from people that are not interested in the new system. Yeah. So you end up with a situation where perhaps your results are going to be skewed more to the positive side, right, of the new system. And that might not really be a true reflection of what is actually on the ground. And it turns out really that low response rates here can threaten the validity and generalizability of your research, right? Ruling out the possibility that the results that you have obtained or gotten are by chance. Yeah. Anyways, hope this is all making sense. Now, sometimes it becomes so bad that you know, you know, students sometimes are funny. You have discussion like this, and then when they're actually doing this in the real world, like at fourth year, and they present, you know, this perception that they were not really paying attention during class, right? For 2 weeks, I've been having the same conversation with students. No, so we haven't interviewed any lecturers because lecturers are not, we can't find them, you know, they're not responding, they're not receptive to the idea of us sitting in their classes to observe them. I'm telling them, well, I mean, you're not persuasive enough, right? You know, when you're recruiting people to be a part of your study, yeah, you have got to be persuasive enough. Maybe, for the example of students who are building this attendance system here, telling them part of being persuasive is to emphasize that there's a likelihood that what we are building here can be something that you can use to take attendance if you're handling very large classes. And somebody will get excited about that. You know, I don't know. It's crazy here. Anyway, so this brings us to a question, I mean, to important topics. So we're looking at challenges with participant recruitment here. But the question now is, how do we determine the sample size, right? You know, we're working with 30,000 LUNZA students. I mean, how exactly do we know what number is appropriate? So it turns out that determining the sample size for a study is an important part of the study's design itself, right? Because the goal is always to include sufficient numbers of elements or cases, right? The larger the sample size, the better the accuracy, if you will, and reliability of your findings. More importantly, especially when you're conducting quantitative studies, the goal is always to be able to generalize, is it? Even if I'm going to collect data from 300 UNZA students, I can generalize my findings. I want to be able to generalize my findings to the entire UNZA population. And it turns out that you can do that. You can confidently tell people that you're able to generalize your findings if your findings are statistically significant, right? So in some of the papers that I've given you, there's mention of things like, oh, the p-value is less than 0.05, for instance, yeah? Or it's less than 0.001. What you're telling people is that we can confidently say that the findings that we obtained are not by chance. And more on that when we look at, when we start day after tomorrow, when we start looking at, data analysis, ideally, right? So again, we're saying here that determining the sample size is crucial in research because it affects the accuracy of the findings, the reliability of the findings, and also the generalizability of the findings. Yeah, we want to be able to reliably tell people to say 21.8% of Zambians consume alcohol, or rather 21.8% of Zambians between the ages of 18 and 69 consume alcohol. Yeah, we're able to do that because in as much as we worked with, 5,000 households, we're able to confidently generalize our findings to the entire population of Zambia. It's like 18 plus million, right, people, based on like this 5,000 data points. Anyhow, that's fine. And really what we are saying here, if you notice, we are highlighting three key things here, right? In terms of accuracy and reliability and generalizability. So I thought would mention these three key things. We're saying that the sample size has implications on the accuracy of your findings, the reliability of your findings, and the generalizability of your findings. So in terms of the accuracy here, we see that there's a likelihood that, or rather, your sample size is going to have implications on the degree to which you can reduce the sampling errors, right? Remember sampling errors, yeah? We see here that larger sample sizes will help reduce sampling errors, right? Yeah. And then also, what you're doing here by reducing sampling errors here is you're ensuring that your findings are closer to the true values of the population. Okay. Again, tied to accuracy here, your sample size, if it's large enough here, is going to improve the precision, right? So in other words, you're going to have a more precise estimate. Remember, when you're collecting data from a sample, right? A representative sample of the population. It's an estimate. It's not an exact science. It's not an exact science because you're not collecting data from everybody, right? But from a representative sample of that particular population. So because it's an estimate here, it turns out that the sample size here is going to ensure that you have something that is much closer to the truth, a more precise estimate, in other words, right? In essence, what we would have is a situation where your findings are going to be much more consistent and reliable to a certain degree, not completely, but to a certain degree. And really, this makes sense, right? Because in studies like these, it's like if they're going to feed into policy implementation, you know that you're making a decision based on something that can be trusted. It's not exactly that, but something that can be trusted. Yeah. Anyways, and then in terms of reliability, what your sample size will do is they will increase the statistical power, right? Which is really the ability to detect any significant differences or relationships. Yeah. So for instance, if you're looking at significant differences between specific demographic factors or characteristics within your population, right? And what we see here is that tied to reliability, there's this reduction, right? If you have a representative sample, right, a significantly larger sample size here, you're reducing the likelihood of what are called type 2 errors here. And we'll talk about these sort of errors during our discussion of data analysis of quantitative data especially, right? But the idea behind type 2 errors here is you find yourself in a situation where you fail to detect any real effect, for instance. But also, we see that tied to reliability here is the strengthening of confidence intervals, really, right? Again, we'll get to discuss this issue of confidence interval very, very soon when we start looking at data analysis, if you will. Hopefully that will make sense here. And then the issue of generalizability is tied to you being able to use the findings collected from your sample to be able to extend them to the entire population. Yeah. So larger sample sizes are more likely to be representative of the population. If I'm conducting a study at UNZA and I just collect data from 20 students, it's like 20 out of 30,000 students, right? That sample is so small, is it? And because it's so small, it's not representative of the entire population, right? Because it's not representative of the entire population, I won't really be in a position where I'll be able to capture the diverse nature of the population, right? You have people of different ages, people of different backgrounds, people that are doing different programs, right? You understand here? So it makes life a lot difficult here if your sample size is much smaller. So your generalizability is increased, or the extent towards which you can generalize your findings is going to be increased if your sample size is larger, right? Making it possible for you to be able to apply these findings to a broader population. Here's the thing. If you, as you're conducting your studies, if you find yourself collecting data from the School of Education, you want to add that as a limitation, right? Instead to say these findings are just restricted to the School of Education, because you would know beforehand that if you had conducted a similar study, maybe the School of Engineering, especially those people doing sanitation, the findings would be different. Yeah, findings would be different. So in that particular case, it's almost as good as you saying, well, we can only generalize these findings by localizing them to the School of Education. That's it. Because it may just be the case that sanitation is not a problem in the School of Mines or in the School of Engineering, for instance. Anyways, again, just to mention a few things here about trying to see if we can, 47 here. We're almost there. Yes. Yes, Mr. Oliver, sir. I don't know if that was a mistake here, but anyway. So a few things here on the implications of using a smaller. Yes.
Oh, sorry, I turned on the video. What's this icon before the audio? The question, doctor. when you are conducting such sampling sizes, are there any ethical considerations that you should also consider as well? Because I've like as much as I've seen like you were talking about, how to conduct them and specifically, do you also need to consider ethical considerations in a field like in terms of like persuading them to answer your specific questions in that field?
Well, I mean, I don't know if you have a specific example here, right? I mean, persuasion comes in different forms, right? There's a school of thought which argues that giving people sort of like rewards or something for participating in a study is a form of coercion, right? So people are not, if you're telling people that, I'm going to give you 50 kwacha, it's like me right now, right? If I was conducting a study at UNZA and I just launched the study, the response rate is going to be extremely low, right? Than if I said, what I'm going to do is I'm going to give you 50 kwacha for lunch for your time or something like that. So, I mean, the line is a bit blurry here in terms of voluntary participation, because one would argue that somebody is not really voluntarily but agreeing to be a part of this. It's like there's some sort of coercion, is it? So, I mean, I don't know. I mean, the things that we discussed as part of ethical consideration apply here. Like, I want to really highlight the more crucial ones. Like, if you're dealing with minors, you just do not take this informed consent form to a minor, is it? You must take it to the guardian, for instance. It's things of that sort, right? When you're collecting data, you want to make sure that you collect this data in ethical manner here. But I don't know what you are hinting at here in terms of, maybe if you can use an example, a specific example, it will help us address your question or something.
I'm saying like there was something that you mentioned specifically, like sort of like persuasion, like persuading them in terms of like questioning that, because there can be questions
No.
that
So the word
might be
persuading.
detailed.
No. But persuading somebody doesn't necessarily mean that. Persuasion is tied to the recruitment process, right? You're trying to reach out to this person to explain to them that they should participate in this study. So persuasion can mean what? Can mean sending reminders. I launch a survey, right? I tell you there's this survey that is available. And maybe 2 days later, only 3 of you have responded. The way I can persuade you to respond to this is I can rephrase, right? If I'm sending this via email, I rephrase the email, the wording of wording as WORD here, right? ING. The wording of my invitation for you to participate. That's what I mean by persuading, not really persuasion in the in the classical sense, not what you're thinking here. And I wanted to maybe showcase something here, right? I think it's um, I don't know if it's here where we were. I was worried that I was really worried that the responses we had gotten were just so they're not sufficient here. And so what I did was I did something like this, right? I did something I reworded, because my colleagues from UTH, Dr. Chiwuta and Dr. Zulu, were the ones that were handling this, right? And so what I suggested was, can we maybe, if you notice here, and I'm glad you asked this question, right? I don't know if you can see here. I'm going to start off by going here. I was reminding them, we have 61 responses still, right? I'm wondering if there's more we can do. This was in June, right? More we can do to push for more, right? Perhaps we can take advantage of the weekend and resend messages and stuff, right? So what I'm defining as persuading, guys.
Yes, you can get you, doctor.
Okay. Yeah. So engaging, right, with individuals, the art of persuasion, and then I respond, right, and saying perhaps we can also attempt to alter what we are sending to them, right? Because if you're sending this via WhatsApp, it's like people see a whole ton of messages on WhatsApp. You know, you send a message on WhatsApp, and 5 minutes later somebody is going to send a meme, and that thing is gone, right? Maybe very people will see it or something like that. You know, so let's change the message, and then to persuade them, what I suggested was, let's use this message. And by the way, from 61, we eventually got to, at some point towards the end, we got to 93, right? So it's not persuasion in the classical sense, not what you're thinking here, where you are there's a difference between persuading somebody and coercing them. If I'm conducting a study with you, and I am hinting at the fact that if you don't participate in this study, the test is going to be hard here. That's no longer persuasion, right? That's coercion. All right. And you're being unethical when you start coercing people to be a part of your study. Why? Because you're going against the fundamental principles associated with ethics, is it? It must be voluntary participation. Anyhow, so we see here that some of the implications associated with small sample sizes here is underpowered studies. Most of these things we've mentioned here. So smaller samples will not have enough statistical power to detect significant effects. Inaccurate estimates, because you're doing a projection here, right? Smaller samples can produce bias and unreliable estimates, so the precision will be lowered significantly. Limited generalizability, right? You won't be able to extend the findings. You can't confidently say, as much as we collected these results from 30 students, we can generalize them to the entire 30,000 students at UNZA. Like how, right? And then increase the risk of type 2 errors, right? Where you're failing to detect any real effect here. And then again here, you mustn't really get excited here. We see that if you get excited with this notion of working with a larger sample size here, there are drawbacks, right? There are implications on how much time you're going to have to spend on the study, because you're collecting data from significantly more elements or cases. But also, it's like the cost, is it? Or time cost, is it? You'd have to direct more resources, more money, collecting data from a large sample size, especially for certain types of measurement instruments like interviews, for instance. Or there's a group which is going to be going around here measuring speeds. It's like more time for you. If you are saying we're going to go to the School of Education and then we will, and you can make this exciting enough, right? We want our findings to be so interesting. What we'll do is we'll go on the first we'll go on the mature square, and then we'll go somewhere in the car park to collect measurements of these internet speeds. And then we'll go on the first floor of the School of Education building. We'll go on the second floor, the third floor, the fourth floor, the fifth floor. It's like, okay, we're going to go on the first floor and go to the east wing and the west wing. Okay. Second floor, east wing, right? And also the midpoint or something. It's like, but how many measurements are you going to collect, right? It will probably take you a whole week, if not 2 weeks, right, to collect that data. So the implications on cost and time. But also, if you're working with human participants especially, it may be difficult, right? If you are aiming or striving to work with a larger sample size, it may be difficult for you to recruit these participants. It's hard, right, to convince people to participate in studies. Very, very, very hard. I sent you that link, that video from 1987 for a reason, right? To give you an idea that recruiting participants is really extremely difficult. If you notice, those people were moving around at night, the data collectors, right? Looking for prostitutes to interview, Anyways, so larger sample sizes may require a wider pool of potential participants, which can be challenges to obtain here. I'm looking at the time here. We're almost done here. Yeah, almost done here. So just to highlight here some factors still on sample determination here, but some factors that will affect sample size determination here is obviously the total population. So when you're determining, how many people should I collect data from for my study? First thing to look at is the total population size. This is the reason why in research, typically when you're reading these papers, they will tell you that we sampled 100 people something from a population of X. So part of what you do as a process of recruiting these participants, right, is you do your due diligence, your research. If you're working with UNZA students, it's like, how many students are at UNZA currently? If it's full-time students, how many full-time students do we have at UNZA in 2025? Now, I'm sure you're thinking here, but how do we figure that out? Well, it's part of your task, is it? So you start going through the website. There's important documents like the strategic plan for the UNZA and all those things, right, where you can get this information. How about the School of Education? Well, there's important documents. If you can go to the 4th floor here and speak to the administrative assistants here, or maybe the assistant registrar, right, to find out these details. But also, some of the things that you take into account here is the desired level of precision. What is the acceptable error, right, that you are willing to get away with here? Turns out that if your margin of error is quite small, your anticipated margin of error is small, you'd need a large sample size. And then the confidence interval as well, right? Probability that the results will fall within a certain range, is it? So the higher the confidence interval, the larger the sample size that you would need ideally. Some other things here are issues like the effect size here. So the size of the difference between, or the magnitude of the difference between or relationship that you expect to find in your data or your findings. Again, we see a situation where small effect size will require large sample sizes. There are those numbers that you have, right? It's like 95% confidence interval or something, yeah? Heterogeneity of the population, so the variability of the characteristics being studied, yeah? If it's a UNZA, are all the programs represented? Are all the genders represented, right? So if you have a more diverse group population, you're going to need a much larger sample size. UNZA is a classic example, right? Gender, different genders, different ages, different programs, different schools, different departments, right? Insane stuff here. And so because you have all of these different variabilities, you need a significantly larger size, is it, to take into account these things here. But the way to get around this is you do what the researchers for the PrEP study did, right? Where they're telling you that the only thing we took into account is what? Program of study, right? And age. Boom, that's it. Yeah. Anyway, the type of analysis as well, right, will affect sample size determination. If you're going to conduct inferential statistics, numbers are important, right? If it's just descriptive statistics, not so much, right? So we're saying here that certain statistical tests require large sample sizes than others, like descriptive statistics, right? If you're conducting inferential statistics, when we're talking about the p-values and all those things, you certainly need a large sample size. But if you're going to end at descriptive statistics where you're just telling people, oh, standard deviation was this, the mean value was this, the median value, the mode was this, these are the graphs that represent a population, you don't necessarily need a large sample size. Now, this brings us to an important point here to do with sample size calculation, right? The way we're mostly referring to quantitative studies here. It turns out that you can manually compute the sample size using pre-existing equations. There are a number of equations and formulas, number of them actually. And I have a few listed here. By the way, some of these things have got, they've got corresponding calculators online. So all you can do is, you can just say Cochrane's formula right? If you just go online and just say Cochrane's, or maybe Slovene's formula online or something, you have like a calculator, right? That you formula online calculator or something like this. You have like some form that you can use to plug in the values. Yeah, it's as easy as that. You plug in the values and then it kind of showcases to you your sample size. If you notice here, right? And this is say what the hell is this? Yeah, I'm gonna say I want to figure out how many students I want to work with at the University of Zambia using Slovene sample size formula, right? And there's about 30,000 students at the UNZA. Margin of error that I expect is just 0.05 here. I'll just say calculate, and then it's telling me here that I need a minimum of 395, right? Because it's 394.737. You can't have a 0.737 for a person, so we're rounding off to the nearest whole number here. So I would need a minimum of 395, right? Responses. You understand? So there are formulas that you can use, a whole range of formulas. I do encourage you to look into these formulas, ladies and gentlemen. You will have fun doing this. In most instances, you just have to choose one and you should be fine with it. I just need to tell this slightly delayed. We'll join class in the next 5 minutes. And should students sometimes get excited. You understand this? So there's a range, right, of common formulas that you can use. There are a lot of formulas out there, but these are some of the most widely used or popular ones. You'll find people in the write-up to say, well, I use Cochrane's formula, right? Yeah. Or I used Yamani's formula or something like that. Yeah. Anyways, the advantage with using a sample size calculator, right, an established way of calculating your sample here is it provides a clear understanding of the underlying calculations. So if you just read up on how Cochrane came up with that formula, to have an explanation for how this is being calculated. But also you avoid the requirement or this question, avoid answering a question of how did you arrive at that sample size. If you just tell somebody, I use Cochrane's formula to compute this, that's it. They won't even ask you more questions. Maybe the only question they'll ask you is how does this formula work or something like that. Just to mention here that sometimes the manual calculation can be time consuming and prone to errors, especially for complex studies. It may require knowledge of statistical components and formulas as well, right? Anyways, so this is the manual process, right? There are tools, and I was getting ahead of myself. I was mentioning what I was saying here is there are formulas. You can do this manually if you have the formula, right? You can manually compute this yourself, or alternatively, you can use formulas, right? Software rather, like this, a software tool to do a computation for you. And I do encourage all of you to just use a software to do this. You don't have to, we are in 2025, ladies and gentlemen. Why would we have to manually do things here when they're calculators, right? Of course, we need to understand these formulas here. It's going to be more efficient for you and accurate. There's less likelihood that you come up with some erroneous sample size or something. They'll enable you to handle complex scenarios here and statistical tests here, and also provide you visualizations and reports in some instances. I don't know. Yeah, but also, so what you can do is you can refer to existing studies. Usually, this is a good enough starting point. As you are reading up during the literature review, I'm sure you've come across articles that will state this is what we use, right? This is what we use, and so what you can do is you can latch on to the technique that was used in existing studies. If you can trust that study, and then apply it to your work, yeah. That way you have a basis for comparison ideally. So it provides a benchmark for similar studies, and it can be really a quick and easy reference. You can even cite them. We used the technique used by Pierre et al. Or something to compute our sample size. That's it. you know. Yeah, I don't know. So just a few guidelines here, rules of thumb for computing your sample size. You know, just use general guidelines and conventions for determining your sample size. In some instances, for most human-computer interaction problems, for instance, people will tell you a minimum, for instance, of this number is enough for statistical analysis or something like that, right? So there are some studies out there that will indicate that, you know, a minimum sample of about 30 for most statistical analysis would be sufficient. Or they'll tell you that if you're conducting a survey or something, you need to have at least 100 participants, right? These are just rules of thumb, not backed up by science here. I guess the people that have looked at a whole range of historical studies that have been conducted, and they figured out that this is, I guess, an appropriate number or something. And then, obviously, the rule of thumb for qualitative studies, like interviews, would be saturation, right? Data saturation. If you get to a stage where the responses you're getting from participants is more or less the same, then you know you can stop here. Right? So it turns out that, you know, using rules of thumb, for instance, or rule of thumbs, can be advantageous in that this is simple, isn't it? You don't have to start reading up on what is Cochrane's sample size formula or something, or your Mani's formula, right? All you're doing is you're latching on to what is being stated. So it can be simple and easy to apply, can provide you with a reasonable starting point, a good enough starting point. However, it may not be appropriate for all situations. Maybe your study has certain characteristics that are different from what is being prescribed as guidelines or something. And as a result, you end up with a situation where you have like an oversampled or underpowered study, ideally. So just a few examples here before we wrap it up. For quantitative studies, right? What we're saying is that typically a reminder that the goal here is to ensure that the sample is large enough to be statistically representative. Remember, generalizability is key here, right? You should remember those key, accuracy as well, right? These things here. When you're dealing with quantitative studies, these things are important. Accuracy, reliability, and generalizability, is it? Yeah. So because of this, you know, to calculate your sample size, you need to decide on three key things: the population, total number of people in your target population, the confidence level, to what extent do you want to be certain, right, of the results themselves? Like, oh, to 95%, right? And then the margin of error, right? You know, how much errors are you willing to accept? So all of these are important. These are important variables to take into account when you are determining sample size. And in fact, if you look at most of these calculators, like Slovene sample size formula, what you notice is that when you're determining the sample, which is n, sample size, which is n, you take into account the total population, uppercase n, and then you divide it by 1 plus total population multiplied by exponent raised to the power 2 here, margin of error, right? So you notice that all of these things we're plugging in. Uppercase n here is the total population, n, and then e is the margin of error here. Typically, margin of, you can get away with 0.05. It's a standard anyway, 0.05. And so computing this, when you plug in the values, you notice here that if our population in the School of Education, for instance, was 2,000 students, if we plug in the values here, 2,000 divided by 1 plus 2,000 raised to 0.05, 2,000 times 0.05 raised to the 2, will end up with 333 students. Just to mention here that when you are dealing with qualitative studies, however, the goal here is no longer tied to things like generalizability and all those things. You're interested in understanding, right? You're getting an in-depth understanding of something, a phenomenon, for instance. So you don't use formulas in this particular case. However, the sample size is typically guided by what's called data saturation. So the point at which you, in your data collection, there's no new information that is coming your way. You interview Lighton, and then you go and interview Pierre or something, and they're telling you the same things over and over again. So you stop, which is why typically they'll tell you that when you're conducting interviews, you can just interview 5 people or something. That's coming from somewhere. From past studies that have been conducted, when you get to a stage where you've reached the 5th person, you reach a data saturation point here. You start hearing the same things over and over again, and it's pointless at that point for you to gather more data here, right? And I thought I would leave you with data coming in from Creswell's classic here, right? So it's design. Trying to answer the question, how many interviews are enough? Practical rules of thumb in that classic. And he states that whilst the true answer is it depends on data saturation, in some instances, there are these guidelines, right, that are widely accepted. If you are conducting a case study, for instance, 4 to 5 cases are sufficient. You know, if you are looking at general qualitative study, 15 to 20 interviews are credible, something like that. Grounded theory, 20 to 30, and all those things. I think there's a question here. I'm going to pause. I was really looking forward to us getting this out of the way completely. I don't know if there's a question. No question. All right, listen, everybody. Sorry about that, everybody. I lost connection, I believe. But I was reminding you that we have class. I mean, we have a test tomorrow at 18 hours in Michael Kelly Lecture Theatre. We will not have class at 17 hours, so take note, because we have a test, right? So I'll see you tomorrow at 18 hours. If you're one of those people who's affected by the fact that you're doing a second-year course where we have the test again, yeah, you want to reach out to me so that we can quarantine you or something like that. So you will write your test at 19 hours. I think there are a few of you that have reached out to me. Thank you very much, and bye for now.